Welcome, everyone! Today we're diving deep into one of the most fascinating and perplexing figures in ancient philosophy, Zeno of Elea. His paradoxes have challenged the minds of philosophers, mathematicians, and scientists for centuries. Are motion and change truly real? Or are they mere illusions? Stay with us as we explore Zeno's philosophy, his paradoxes, and what they reveal about the nature of reality. Let's get started. Zeno's philosophy. When the foundation of Eleatic. Thought Zeno of Elea, c. 490-430 BCE, was a pre-Socratic Greek philosopher and a disciple of Parmenides. He is best known for his paradoxes, which challenge our understanding of space, time, and motion. Zeno's work was primarily an extension of Parmenides' philosophy, which argued that reality is singular, unchanging, and indivisible. Aristotle, in his work Physics, credits Zeno as the first to develop the dialectical method, a form of reasoning that involves refuting opposing arguments through logical contradiction. Zeno's paradoxes serve to demonstrate that accepting plurality and motion leads to logical inconsistencies, reinforcing Parmenides' doctrine that reality is one and motion is an illusion. Zeno's paradoxes, a challenge to common sense. Zeno formulated several paradoxes, but the most famous ones focus on the impossibility of motion. These paradoxes have been analyzed for centuries and continue to inspire discussions in philosophy, mathematics, and physics. Let's examine some of the most well-known paradoxes in detail. Achilles and the tortoise. This paradox proposes a race between the swift Achilles and a slow-moving tortoise. Achilles gives the tortoise a head start, but according to Zeno's reasoning, Achilles can never overtake it. By the time Achilles reaches the tortoise's initial position, the tortoise has moved forward slightly. This process repeats infinitely, meaning Achilles can never pass the tortoise. Aristotle attempted to resolve this paradox by distinguishing between actual and potential infinity. Later, mathematical developments in calculus, particularly limits and convergence series, provided a framework to reconcile the paradox logically. However, the deeper philosophical implications remain thought-provoking. The dichotomy. Paradox Zeno argues that before one can reach a destination, they must first reach the halfway point. Before reaching that halfway point, they must reach the quarter-way point, and so on. This division continues infinitely, implying that motion is impossible because one must complete an infinite number of steps in a finite amount of time. This paradox raises questions about the nature of infinity and how we perceive continuity. The modern mathematical concept of converging series shows that an infinite sum can still have a finite value, thereby resolving the paradox in numerical terms. However, the fundamental question about whether reality is composed of discrete points or continuous motion persists in contemporary physics. The arrow paradox. In this paradox, Zeno argues that if we observe an arrow in flight at any single instant, it appears motionless because at that exact moment it occupies a fixed position. Since time is composed of a sequence of such instants, and the arrow is motionless in each, motion itself must be an illusion. This paradox introduces a philosophical challenge to our understanding of time. Is time composed of discrete snapshots, or is it a continuous flow? Modern physics, especially through Einstein's theory of relativity and quantum mechanics, has offered new ways to approach this question. But Zeno's paradox continues to influence discussions on time and motion, the nature of reality. What Zeno's paradoxes teach. Zeno's paradoxes push us to reconsider fundamental assumptions about the nature of space, time, and motion. They foreshadowed many of the questions that later philosophers and scientists would tackle, including issues in calculus, quantum mechanics, and relativity. Philosophers such as Bertrand Russell and David Hume grappled with these paradoxes, with Russell remarking that Zeno's insights were crucial in understanding the nature of continuity and infinity. In modern times, thinkers like John D. Barrow and Roger Penrose have linked Zeno's paradoxes to unresolved issues in physics, such as the Planck scale and the granularity of space-time. Modern interpretations and implications, mathematical resolution. The development of calculus by Newton and Leibniz allowed for the summation of infinite sequences, resolving the numerical aspect of Zeno's paradoxes. However, philosophical debates about the nature of infinity persist. Quantum mechanics. In the quantum realm, the idea of discrete space-time has gained traction, suggesting that Zeno's paradoxes may align more with modern physics than previously thought. Relativity and time. Einstein's theory of relativity, which treats time as a dimension intertwined with space, adds complexity to the discussion of whether motion is absolute or relative. Final thoughts. Is reality an illusion? Zeno's paradoxes remain one of the most enduring philosophical challenges in understanding reality. While mathematics and physics have provided tools to navigate these logical puzzles, the deeper metaphysical questions remain open-ended. Are space and time truly continuous? Or is our perception of motion merely an illusion? Zeno's work continues to inspire not only philosophers, but also scientists, mathematicians, and curious minds worldwide. And that's a wrap on today's deep dive into Zeno's philosophy and paradoxes. We've explored how his ideas challenge our perceptions of motion, time, and reality. But what do you think? Are these paradoxes just clever word games, or do they reveal something deeper about the universe? Let us know in the comments below. And don't forget to like, share, and subscribe for more thought-provoking content. See you in the next video.